Imagine sailing across an endless ocean. For weeks you see nothing but water stretching to the horizon. Now picture that same journey, but in the vastness of space. You travel for millions of years, past glittering stars and swirling galaxies. But then you enter a region where everything stops. The lights go out. The cosmic sea becomes a silent, dark, and profoundly empty abyss. This is not a work of fiction. This is a real place in our universe. A place where it seems the universe itself ran out of things to make. A place that challenges our very understanding of how the cosmos was built. It is a cosmic mystery of the highest order, a profound silence in the grand symphony of creation. This immense region of nothingness has a name. Scientists call it the Bootes Void. It is sometimes known, more ominously, as the Great Nothing. So, where is this great emptiness located? To find it, you would need a map of the universe, one that extends far beyond our own Milky Way galaxy. If you look into the night sky in the direction of the constellation known as Bootes the Herdsman, you are looking towards this cosmic enigma. In 1981, a team of astronomers led by Robert Kirshner was conducting a survey of galaxies. They were using the telescopes at the Kitt Peak National Observatory to measure the redshifts of distant galaxies. Redshift is a phenomenon where light from objects moving away from us is stretched to longer, redder wavelengths. As Kirshner and his team plotted their data, they began to notice something strange. In a specific region of space, in the direction of the Bootes constellation, the galaxies simply vanished. At first, they might have suspected an issue with their equipment or a simple gap in their data collection. They had stumbled upon a region of space of unprecedented size that was almost completely devoid of galaxies. The team announced their findings in a paper titled "A Million Cubic Megaparsec Void in Bootes." The discovery of the Great Nothing sent ripples through the astronomical community, challenging the prevailing ideas of a relatively uniform universe. It is one thing to say the Bootes Void is large. It is another thing entirely to comprehend its size. The void is estimated to be nearly 330 million light-years in diameter. Our own Milky Way galaxy, a vast island of some 200 billion stars, is about 100,000 light-years across. This means you could line up more than 3,000 Milky Way galaxies, end to end, to span the diameter of the Bootes Void. And still, you would find almost nothing inside. It is a cosmic desert of unimaginable proportions, a kingdom of emptiness that dwarfs anything we have ever known. If you were to board a starship capable of traveling at the speed of light, a feat forbidden by the laws of physics as we know them, your journey across this void would be a long one. It would take you 330 million years to cross from one side to the other. During this immense journey, you would witness the birth and death of entire star systems in the distant universe outside the void. Imagine our Milky Way galaxy as a single grain of sand on a vast beach. On this scale, the Bootes Void would be a colossal empty crater on the beach, hundreds of meters wide, where someone has scooped out nearly all the sand. The few galaxies that have been found inside it would be like lone, isolated grains of sand missed by the scoop, separated by immense distances of pure emptiness. To understand how a void could form, we must first understand the structure of the universe itself. This web consists of dense filaments of galaxies and dark matter, stretching across billions of light-years. Where these filaments intersect, we find massive galaxy clusters, the great cities of the cosmos. Think of it like soap bubbles in a sink. The walls of the bubbles are where the soap and water have collected. This is analogous to the filaments and clusters of galaxies. The empty space inside each bubble is a void. Our universe is filled with these bubbles. Voids are not a rare phenomenon. They are a fundamental component of the cosmic structure. The formation of this cosmic web began shortly after the Big Bang. In the very early universe, matter was spread out almost perfectly evenly, but there were tiny quantum fluctuations, minuscule variations in density from one place to another. Over cosmic time, gravity amplified these tiny differences. The slightly denser regions pulled in more and more matter, growing into the galaxies and clusters we see today. One of the leading ideas is that the Bootes Void is not a single entity that formed in isolation. Instead, it may be the result of a cosmic merger. The theory suggests that the region where the Bootes Void now exists was once populated by many smaller, more normal-sized voids. Over the course of cosmic history, as these smaller voids grew, their boundaries, the walls of galaxies separating them, began to thin out. Think again of the soap bubbles in a sink. As you watch them, you will see smaller bubbles merge together to form larger ones. Cosmologists believe a similar process may have happened on an epic scale. The smaller voids in the Bootes region expanded and merged, their separating walls of galaxies dissolving or being pushed aside. This theory elegantly explains not only the void's immense size, but also the presence of the few lonely galaxies found within it. While the merging void theory is compelling, some scientists wonder if the Bootes void might be pointing towards something even more profound. One exotic idea relates to the nature of dark energy, the mysterious force causing the universe's expansion to accelerate. Perhaps the immense emptiness of the Bootes void creates a unique environment where the effects of dark energy are different, pushing matter away with even greater force. Another fringe but fascinating possibility involves cosmic textures. These are hypothetical defects in the fabric of space-time, predicted by some theories of particle physics. A cosmic texture, if it existed and then unraveled, could have released a tremendous amount of energy, pushing matter out of a vast region and creating a giant void. These more exotic explanations remain highly speculative. They are on the frontiers of theoretical physics, ideas waiting for evidence that can either support or refute them. The profound emptiness of the Bootes void naturally sparks a more imaginative and unsettling question. Could something be hiding in there? While we define the void by its lack of visible galaxies, which are made of ordinary matter, we know that ordinary matter only makes up about 5% of the universe. In a region with almost no visible matter to act as a tracer, it is incredibly difficult to say for certain how much or how little dark matter resides there. Could the void be the home of a civilization so advanced that it defies our understanding of life and technology? Perhaps a Type 3 civilization on the Kardashev scale, capable of harnessing the energy of an entire galaxy, would have different priorities. Maybe they would value silence and solitude, intentionally clearing out their cosmic neighborhood to create a domain of perfect isolation. We have journeyed to the edge of a great abyss, a place defined by its profound lack of substance. The Bootes void is a humbling feature of our universe. It is a stark reminder that the cosmos is not only stranger than we imagine, but it may be stranger than we can imagine. It is a physical manifestation of a question mark, a cosmic silence that invites us to listen more closely to the whispers of creation. The study of this great nothing continues. With each new telescope, with each more detailed survey of the sky, we refine our map of this empty kingdom. We measure the cosmic microwave background radiation that passes through the void, looking for subtle temperature shifts that could tell us about the nature of dark energy within its boundaries. Each new piece of data is another piece of a puzzle, billions of years in the making. The existence of the Bootes void teaches us a valuable lesson about perspective. From our vantage point on a small, rocky planet, the universe can seem full and vibrant. The universe on its grandest scale is a place of extremes, of incredibly dense clusters and profoundly empty voids. It is a place of structure and chaos, of light and of an overwhelming darkness. We are inhabitants of a filament, looking out across an ocean of nothing. And so we are left with the ultimate question, the one that echoes in the silent expanse of the Bootes void. As we stand at the shore of this 330 million light-year-wide emptiness, we must ask, is this the biggest secret the universe has to offer? Or is it just the first of many such mysteries? If a structure this large can exist, challenging our models and our intuition, what other impossibilities are waiting to be discovered in the unobserved corners of the cosmos? What lies beyond the edge, not just of the void, but of our own understanding?